Welcome, dear students, to our first video session dealing with sets and uh, the chapter may seem quite simple and straightforward, but it's it's of considerable importance not only from the examination for point of view, but also in solving problems and understanding problems and other chapters like relations, functions, and even we can use it in calculus. So let's go into the theoretical portion now. A set is defined as a collection of well-defined objects. Collection means aggregation. You're bringing objects together, and in set language, objects, the constants, those which you bring together are called elements. So a collection of well-defined objects. And if you ask me, I'd say the most important part of this definition is this part, that is the well-defined. Now, sets are usually denoted by capital letters like A, B, and the elements are denoted or written in the form of small letters, that is lowercase letters. And here we have a very straightforward and clear example of a set A, which consists of the vowels of the English language. And when you state like that, there's nothing, there's no doubt in which elements you ought to choose, and not the fact that the elements are separated by commas. Now let us look at the key point of what is meant by a well-defined. Suppose in your class the tutor tells you that I create a set of integers. Naturally, there could be different cases. Suppose a student uh, brings forth or creates a set B on, which consists of numbers 6, 7, 8, and another student B2. She comes up with another set, and here the elements are different, that is 66, 70, and 90, and yet another one creates a third set, that is B3. Here it's the negative integers. Now the point here is that based on the statement of a statement about the set, all the three cases are right, because all of them are dealing with integers. Now one point I must reiterate is that in a particular problem situation in sets, you can say a set of integers, which means a infinite set. But here we are bringing out this point to look at what well-defined means and what are the constructions in such a case. Now, the point here is that if a particular operation, if a particular union or intersection, we'll be looking at all those operations in due course. So, if the tutor tells to create a union between two sets, which set will you choose? So you can see that a lot of confusion would be created. But suppose its father stated that choose the integers between 6 and 10. That is, 6 is less than x is less than 10. In that case, no one is in doubt about which numbers ought to be chosen. And another interesting case is, suppose the elements of a set is dealing with the tall students in a class. Now that's very vague. Tallness, we know what exactly it means. So how much tall, and in which metrics is it based? Is it in feet or centimeters, or is it in meters? So there's a lot of confusion. And which class is it dealing with? The music class? Suppose you are attending a music class, so is it dealing with the music class you are attending, or is it the class in your school, or is it a particular division of a particular class? So suppose it's stated suppose the statement is once again specified as tall students between 6 and 7 feet who are studying in the C division of standard 12 in in the school in which you are attending. So it simply means the students who ought to be chosen, that point is very clear, and there's no doubt in choosing the elements in this particular case. So that shows the key point, that as far as sets are concerned, the character of the element ought to be very precise. So in other words, the elements ought to be definite.